Okay, uh, welcome you all for third lecturing of your second model in control engineering. Okay, so today classes we are going to discuss about the modeling of mechanical system. So in the previous class also we discussed about the modeling of mechanical system. So what is the modeling of system? So what type of system we are going to model? So there are mainly three types we have chosen, that mechanical, thermal, hydraulics and pneumatics. Okay, electrical systems. So these systems are going to be modeled. Okay, now first we will start with the modeling of mechanical systems. So in the mechanical systems, motion can be of different types. So already we discussed about these. What type of motions? Those are translation system and rotational system, or sometimes it may be a combination of both, or sometimes it may be a combination of translation as well as rotational system. So already I told you that the system is said to be a mechanical. Is a system is said to be a mechanical if it is having translation motion or a rotational motion. You can take any type of system. If the system is having the motion, which type of motion, either it should have a translation motion or it should have a rotational motion, or sometimes it should have combination of both the motion. Only such a type of systems are called as a mechanical systems. Okay, so now we are going to modelize that mechanical system. We are going to modelize. How to modelize that mechanical system? By mathematical equations, by mathematical expressions. Okay, the equations governing such a motions is obtained by Newton's law of motion. Okay, so for mechanical system we are going to apply some basic laws, in order to express it in mathematical formulations. So for that we are going to apply the Newton's law of motions to the mechanical systems. So in the mechanical system there are two types of systems: translation system, rotational system, or sometimes the combination of both the systems. Okay, so in order to get the mathematical formulations, we need to apply some basics laws. For mechanical system we are going to apply the laws, that is Newton's law of motions. Why we are going to use this laws? Because it is stated regarding the motions. It states that regarding the motions. So that's why we are going to apply uh, this Newton's law of motion to the translation system as well as rotational systems. Okay, so now first we can take the translation system. So this will shows the mass. So already I told you that the in the mechanical system we are having three components, three what you call it, elements. So what are those elements? One is mass, another one is spring, another one is damping. Mass, spring. These three elements or components are considered in mechanical system or modeling of mechanical systems. So first we can take that. First one is in the translation system, we can take that mass. So mass. So this is the representation of mass. So we have to express this physical system in the mathematical formulations or mathematical modeling systems. For that we are applying the Newton's law of motion to this physical systems. So what is the law of Newton's law of motion? Is F is equal to mass into acceleration. So F is equal to what? M d square x by dt square. This is the acceleration. M is mass and here the acceleration is d square x by dt square. So you can write that F is equal to m x double dot x double. This indicates what? Differentiations. That x dot dot, that double dot. It is representing the d square x by dt square. That is a double differentiation. Second order differentiation. You can say it is a second order differentiation. So this is what? F is equal to m x double dot is representing the mathematical modeling of mass in the translation system. F is equal to m x double dot is representing The mathematical modeling of mass in translation system. How will we get this mathematical expressions? By applying the Newton's law of motions. How to get this? By applying the Newton's law of motions, we can get that mass. We can get that mathematical expression for this mass in the translation system. Okay, so first, modeling of mechanical system, we are having three elements or three components. Those are mass, spring and damping. Okay, for first we can take that mass. So to this we are applying the Newton's law of motions. So that is F is equal to ma, or F is equal to mass into acceleration. M mass is represented with capital M, then the acceleration is represented with d square x by dt square. So that we can write F is equal to m x double dot. F is equal to m x double dot. Okay. Now let's move on to the next one. So here first element is mass. Now second, we are going to take it as a spring. Second one is spring. So that it is a physical representation or physical system. It's showing the physical system of a what? Spring. So here in the previous one it is yeah, mass is there. Here in this system we are having spring. So here this K is representing the spring constant. K is representing spring constant, and this is a displacement taken by the spring. Displacement taken by the spring, that will show in x of t. X of t. So that spring F is equal to, again we are going to apply the same law, Newton's second law, to these spring systems. We get that F is equal to kx. F is equal to kx, where k is equal to spring constant. K is equal to spring constant. Okay. So next next is a damper. Next is a damper. So this is representing the physical system of a damper. Just you have to remember the symbol, how to representing the spring, and how to representing the damper system, and how to representing the mass. You have to remember these. Okay. So here it is showing the damping system. It's showing the damping system. So again BRC. Sometimes you can use the BR and sometimes you can use C. So that is nothing but damping coefficient. Damping coefficient. In the spring we get that K is a spring constant, and damper we can get the damping coefficient as a BRC. You can take BRC. So that again we are going to apply the Newton's laws of motion to this damper. So we get that F B into x double dot, B into second order differentiation equations. So this what it represents, F is equal to m x double dot, or F is equal to kx, F is equal to kx, or F is equal to b double dot. So all these are representing the mathematical modeling of mechanical system. Okay. So in the for translation motions, I think you know that a translation system is nothing but what, it should having the oscillations motion. Here it is oscillation, and this is also oscillation motions. Okay. So here these are the mathematical expression or mathematical modeling of a translation mechanical system. So in that again we are considering only three elements or three components. Those are mass, okay, spring and damper. Mass, spring and damper. Okay. Next one is in the mechanical system only. Next type of system is rotational system. Next type is rotational system. So here also we can take that mass, spring and damper. In the same rotational system also we are going to take the same mass, spring and damper. Mass, spring and damper. Mass, spring and damper. So but here the motion of the system is rotational. The motion of the system is rotational, not a translation. Okay, so that's why we are having the different terms here. We are having the different terms. So in the translation system, we are getting the force. That force is getting, that is displacement. Okay, here you can get the torque. That T, it indicates the torque. Okay, so that is apply to the mass. Apply to the mass. How to? By using the Newton's law of motions, we can get that T is equal to J. Instead of M, we are using this here J, d square T by d square theta by dt square. So again you can write that T is equal to J theta double dot, theta double dot. So in the translation motions we can get F is equal to m x double dot. Here torque T is equal to what? J theta double dot. So these are all very important while solving the numericals. While solving the numericals, okay. So you have to remember how to, if in the given system, if it is rotational mechanical system, so we have to write the mathematical expression as T is equal to J theta double dot. T is equal to J theta double dot. So J is nothing but mass momentum. Okay, mass momentum. Okay, so this T is equal to what? J into theta double dot. So if it is a spring, he has given in the control system, if it is a spring, then T, torque, same torque is equal to what? Kt into theta. T is equal to what? Kt into theta. So that is here in the spring, what happens? Displacement also takes place and the rotational also takes place along in the spring constant. Okay. In the along with the spring constant. Okay, that Kt is nothing but what? Spring constant, and here the torque is, it is displaced and get rotated in the rotational system. That's why this T is equal to Kt into theta. But here in the rotational system, if it is a mass, then T is equal to what? J theta double dot. T is equal to what? J theta double dot. Next, third one is damper. If it in the rotational system, if it is in the damper, he has given the damper, just you have to write torque is equal to B into theta. B into theta. Again, B is nothing but what? Damping coefficient. Damping coefficient. So here T is equal to B theta dot. Single differentiation. First order differentiation. T is equal to B theta dot, or first order differentiation. Okay, so these are the mechanical system, modeling of mechanical system by using the Newton's law of motion. Just we have to apply the laws to this system. What are the three main components which we are going to apply the Newton's law of motion are mass, spring and damper. Mass, spring and damper. In the mechanical system, we are going to classify the two types of systems. One is translation system and another one is rotational system. For translation system, again we are going to consider three components: mass, spring, damper. So we have to apply the Newton's law of motion to those components to get the mechanical expressions. Again, in the rotational system, we are going to take the three elements or components. Those are mass, spring and damper. Again, we are applying the Newton's law of motion. Newton's law of motion to that mass, spring and damper in the rotational system. We can get the equations or mathematical modeling of those systems. So these are very important while solving the numerical. So please note down these all formula along with this physical system, how to representing the mass in the rotational system, how to representing the mass in the translation system. So these are all representing these physical system in the and expression of mathematical modeling in the these are all very important while solving the solutions. Okay, so next one is modeling of electrical system. Modeling of electrical system. So in the mechanical system we are having three components. So what are those? Mass, spring and damper. Likewise, here also we are having three components. What are those? Resistor, inductor and capacitor. Resistor, inductor and capacitor. So this is the modeling of electrical system. Similar to the mechanical system, electrical system has a components like resistor, inductor and capacitor. Resistor, inductor and capacitor. So these systems are commonly analyzed by using Ohm's law. These are analyzed by Ohm's law, or you can say that Kirchhoff voltage. So these are the analyzed by using Ohm's law. Ohm's law. So first we can take that resistor. First component is resistor. How to represented this resistor in the physical system? So this is a representation of resistor. Okay, this is a physical representation of resistor. See here, this I is representing current flow and R is nothing but a resistance. Okay, I is current flowing through this wire or circuit, and this R representing the resistor. Okay, so this is written as ER is equal to IR. ER is equal to IR. Ohm's law state that, so that electrons is equal to I into R. Electricity is equal to what? I into R. So this is a multiplication. It is a mathematical expression. How to get this mathematical expression? By using the Ohm's law. By using Ohm's law. Okay. Next one is inductor. That is indicated by letter L. Next one is inductor. So it is representing. So here it is a physical representation of inductor in the control system. So again the current is flowing through this circuit or inductor. Okay. So this is EL. How to representing this? EL is equal to L into di by dt. L into di by dt. Why you can take that L into di by? Why not L into I? So this is avoiding the fluctuations of current through the circuit. So avoiding the fluctuation of current through the circuit with respect to time. So that's why you can take the di by dt. That the characteristics of the inductor is to avoid the fluctuations of current flowing through the circuit. So that is with respect to time. That's why you can take that di by dt, not I into L. You can take that EL is equal to L di by dt. So next one is capacitor. So here again the same characteristics, but it is an integration I dt, integration of I dt. So that EC is equal to what? 1 by C into integration of I dt. EC is equal to what? 1 by C into integration of I dt. The characteristics of this capacitor is also same as that of the inductor. What it does, it avoids the fluctuations in the voltages. Okay, that's why we can take that integration of I dt. So you have to remember all these equations. How to get all these mathematical modeling equations? By applying the Ohm's law. Okay. See here, resistor, inductor and capacitor. Again in the electrical system there are three components, similar similar as mechanical systems. What are those? The resistor, inductor and capacitor. So these systems are commonly analyzed by using Ohm's law. Applying the Ohm's law you can get the mathematical expressions. Okay. So next one is thermal system. Mechanical system, okay, electrical system, and next one is thermal system. So this thermal system can be expressed by using one problem or one illustration. Okay, what he has given, consider a thermometer at a temperature T. So he has given the thermometer here, which temperature is at T, which is just being inserted into a liquid at a temperature TL. So there is one thermometer which is of temperature T, and it is inserted in the liquid. Of temperature TL. The liquid temperature is TL. Develop the differential equation and transfer function. There is a one liquid container. So that liquid temperature is about TL, and there is one thermometer that is inserted in the liquid of temperature. The thermometer temperature is T. So for this we have to develop one equations, differential equations, and we have to find out the transfer functions. Okay, in the thermal system, the thermal systems are like this. So the problems are in the thermal systems are like these. Okay, so now what is the solution for this problem? Okay, from law of conservation of energy we can apply here. So first, how to get, you can take any systems, you can take any control system. It may be a mechanical, it may be electrical system, or it may be a thermal system, or it may be a hydraulic and pneumatic system. So how to get that mathematical expressions? By applying one basic law, by applying one basic law. So in the mechanical system we applied the Newton's law of motion to get the mathematical modeling. In the electrical system we applied the Ohm's law to get the mathematical modeling. Similar way, here in the thermal system we are going to apply the laws of conservation of energy. We can apply different laws according to the situations, according to the applications. Okay. So here from law of conservation of energy, Q1 minus Q2 is equal to Qs. Yes, Q1 minus Q2 is equal to Qs. Q1 is the heat supplied and Q2 is the heat outflow. Okay, since the heat outflow of energy and inflow of energy to the container, and Q2 is outflow of energy, and the Qs is difference between these two, that we call it as a storage energy. So since there is no outflow of energy from the thermometer, there is no outflow of energy from the thermometer. So from thermometer we are not going to lose any energy. We are not going to lose any energy. That's why Q2 is equal to 0. You can take Q2 is equal to 0. Then it becomes what? Q1 is equal to Qs here. Q1 is equal to Qs. That is the equation number A. Equation number A. Okay. So next, also Q1 is equal to C dt by dt. C dt by, we know that Q1 is equal to C delta T. C delta T. That is specific heat into temperature differences. So that is Q1 is equal to what? C dt by dt. Okay. So we know that Q1 is equal to Qs. Just we have to write the Q1. Qs is equal to what? C dt by dt. C dt by dt. So this is equation number 1. This is equation of A, and this is equation number 1. We also know that R is equal to what? TL minus T by Qs. TL minus T by Qs. And you can write that Qs is equal to TL minus T. Qs is equal to what? You can just take this term to this side. QL minus T by R. QL minus T by R. So this is equation number 2. Equation number 2. Okay. Now equating the equation 1 and 2, equating the equation number 1 and 2, see here, equation number 1 and 2. So what will so here you can equate these two equations. First, Qs is there. Okay, C d theta by dt is equal to what? C d theta by dt is equal to what? TL minus T by R. Equating these two equations. Why we are equating? So at the LHS we are having the same term. Qs is equal to C dt by dt, and here Qs is equal to TL minus T by R. Equating these two equations, that is TL minus T by R is equal to C into dt by dt. Okay. Next, TL is equal to, simplified, TL is equal to what? RC ddt by dt plus T. So simplifications. It is a required differential equations. It is a required differential equations. What is that? TL is equal to RC dt by dt plus, this is a plus T. So this is a required differential equations. Here he has given the develop the differential equations. So this is a required differential equations. Now taking Laplace transfer to this equations, TL is nothing but TL of S. It will be TL of S. TL is nothing. It will be TL of S. After applying the Laplace transfer to this equations, we can TL of S is equal to R. It is a constant, so you can kept it as it is. So here C d dt by dt d t by dt. So that is nothing but C S T of S. So differentiation, first order differentiation, now applying the Laplace transfer to the first order differentiation, it will be S T of S. D T by dt becomes S T of S. So here RC S T of S plus, so this is T of S. T of S. TL is nothing but TL of S and T is nothing but T of, so RC S T of S. Next TL of S is equal to simplified RCS plus 1 into T of S. Just you can take TS outside. You can take the TS outside. Okay. So it becomes what? TL S is equal to RCS plus 1, okay, into T of S. Then you can take the transfer function. Transfer function is nothing but what? Output by input. Output by input, that is T of S is output and TL of S is a input. Just you can take the transfer function is T of S by TL of S. Then you can take this term here, so it becomes 1 divided by RCS plus 1. 1 divided by RCS plus 1. Okay, transfer function is equal to what? T of S by TL of S. T of S by TL of S. Just you can take this side, so it becomes 1 divided by RCS plus 1. RCS plus 1. So this is our transfer function for the thermal system. Transfer function for the thermal system. Okay. This is the transfer function for the thermal system. So next we are going to discuss hydraulic system. Next we are going to discuss hydraulic system. Okay. So already we completed mechanical system, electrical system, thermal system. Next we are going to discuss about the hydraulic systems. Okay. So in the modeling of hydraulic system is related to design of storage tank, related to design of storage tanks and flow through the pipes, for a fluid. Flow through the pipes for a fluid. Modeling of hydraulic system is related to design of storage tanks. Design of storage tank and flow through the pipes for a fluid. Just we have to model the hydraulic system by in the hydraulic system. Okay, we have to modelizing this hydraulic system by designing the storage tank and flow through the pipes for a fluid. Okay, so now next we have to take let QI is equal to inlet flow rate, QI is equal to inlet flow rate, A is equal to capital A is equal to what? Area of cross section of the tank. Capital A is area of cross section of the tank. Next Q naught is flow rate at outlet, flow rate at outlet. H is equal to height of the liquid, H is equal to height of the liquid. R is equal to what? Resistance, R is equal to resistance, and C capital C is equal to capacity of tank, capacity of tank. So these are the abbreviations which are used in the design of storage tank and flow through the pipes, flow through the pipes. So for modeling of hydraulic system, we can consider the design of storage tank and flow through the pipes for a fluid. So then hydraulic system components can be defined as below. Defined as below. So first hydraulic resistance. First hydraulic resistance. So here there is one container. There is one container. So here that is a C distance and this is the head H. It is the resistance. Okay. The capacity of the tank, this is the capacity of the tank, and the resistance small h is nothing but what? Height of the liquid. So inlet flow rate, that is represented by Q1. So here this resistance, hydraulic resistance R is given by h by q. R is given by h by q naught. So this h divided by q naught is nothing but r. So this is a mathematical modeling of hydraulic system for hydraulic resistance. Hydraulic resistance. Next, hydraulic capacitance. Similar diagram. So that capacitance we have to write find out the capacitance, that is q by h. This q by h. Q by h. The c is nothing but what? Q divided by h. R is nothing but h by q naught. C is nothing but, or c is equal to what? Q by h. So c is equal to, we can write that q, inlet flow rate area into height. Area into height. That whatever the flow rate is there, inlet flow rate is there, that is, you can take that area into height. So that is given the q. We can we know that q is equal to a into v. A into v. So here a into h. C is equal to what? A into h divided by h. So this c is equal to a. C is equal to what? A. H get cancelled. Here C is equal to A. C is equal to hydraulic capacitance. That is C is equal to A. So this is a hydraulic system. Hydraulic system. Okay. So in the next class, we are going to start the block diagram of algebra. Block diagram algebra. So next is a very important topic, block diagram algebra. Okay. So go through this video, and if you have any doubts, you can ask.